Now, having gone through this in the last class, we are going to do some examples on automation of problems in geotechnics, that's soil mechanics. In our last class, we looked at automation of sieve analysis table, which we have done perfectly, but we are going to repeat it once again with examples and the tables that are going to be contained in it, so that we see how it's going to play out. And remember, in our last class, we aren't able to plot graphs, the sieve analysis graph. At this point in this class, we are going to go through all this, as well as go through what we call the infiltration table also. So let's start from where we stopped before. Let's start. The first thing we do is to create, you can create a heading called automated sieve analysis table. So you have created that. So remember what we did last time. So you highlight it, you can bold, you can change the character you can use Arial, change the color by clicking here. Now you can increase the size. So this is it. So here you can also do what we call margin. Can merge across so that it becomes one. So now let's start our table from maybe somewhere here. Okay, now we say our sieve size, after sieve size, we'll have mass of sieve. So let's want this thing to enter into one single of this, so wrap it up. So increase a little bit. Okay, that's the size we're going to be using. So mass of sieve will have mass of sieve plus soil mass of sieve plus soil. We have mass of soil retained. So wrap it, mass of soil retained. The next thing we do mass of soil retained and mass of soil passing. And next thing we have percentage mass passing. So we have our sieve size, we have mass of sieve, we have our mass of sieve plus soil, mass of soil retained, mass of soil passing, and percentage passing. So we know that at the end of the day, we will be plotting a graph of sieve size against percentage passing. So like we said in the other class, these three, the sieve size, the mass of sieve, and mass of sieve plus soil, is gotten from the lab. While these other three, mass of sieve, mass of soil retained, mass of soil passing, and percentage passing, is going to be automated. The system is going to calculate it automatically. So let's try and create these formulas and see how they play out. For mass of soil retained, we are going to have equals to, because we are writing a formula now, it's going to be this one minus mass of sieve. So because it is the same, so I'm going to drag down from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So for the number of sieve sizes. So this is what we got. Now the next one is mass of soil passing. So come here and say total so we have equal to sum bracket open, because you have initiated a function. So you say sum of from here to here, shift brackets, place enter. Now mass of soil passing should be equal to what you have here minus here. The next step is equals to this minus this. So at this point in time, you can drag so that it be all the same. So I've gotten mass of soil passing, I've gotten mass of soil retained. Now percentage passing is going to be equal to the value here all over mass of soil passing here times 100. So now, being that this D for thing, which is the total of the sample retained, is going to be constant, what will be changing is the E value. So because you're going to move from E4, E5, E6 just continuously. So we are going to put dollar sign. One will be at the front of the D. You have dollar sign, and another one will be in front of the number. We have another dollar sign. So it's going to be permanent. So at this time, you can now drag down. So we have dragged down. So we have gotten all this. So what we do now, let's put in some values and see how the system will automate it for us, because we have completed everything. The one thing that is remaining now is to show you how the graph can also be automated. So we have here a 4.75 millimeter sieve. We have 2.0 sieve. We have 0.850, 0.600, 0.425, 0.250, 0.106, 0.075. So I have the complete, and the last one is pan. Now mass of sieve, let's assume the mass of sieve was constant. The mass of sieve was constant at 200. The mass of sieve plus soil, we have 200. I have 240.2, 250.2, 240, 3, 06.4, 3, 308, 259, 208.7. So these are the values. You can see automatically the whole thing have generated itself. I've seen the values. Even as we are typing the values, they are being generated. You can see that the mass of soil retained at 0, at the first point is 0, no soil was retained, and the percentage passing was 100%. Percentage passing was 100%. So let's check. So add dollar sign. You know the essence of adding dollar sign to make sure that everything, so that there is slight mistake we did here in terms of dividing the percentage. It's supposed to be the other way around, so that is why we are changing it. So put the dollar sign. So put the dollar sign here. So at this juncture we can now drag. So this is what we have. So you can see how we are able to generate these values automatically. Immediately the values that we have gotten from the lab were entered. So we are able to get these values. So now the next phase is to plot our graph. Now for us to plot our graph, we are going to highlight the x and the y axis. Remember, on the x-axis we have the sieve sizes, on the y-axis we have the percentage passing. So the first thing we highlight is the x-axis. So we'll come here, we highlight, now we'll hold down control and highlight this one. Now at this point you go to insert, go to scatter, select this one, and this is a graph that we have. Now we need to convert this graph into a semi-log graph. We need to convert this graph into a semi-log graph. So you can take this chart anywhere you want. If you want it to be beside your table, you can do it. If you want it to be under the table, you can drag it. So now the side that is log is the x-axis. So we highlight and we go to format axis. You click on format axis. Now where you have automatic, change it to fixed. So the minimum value should be 0.0001. The maximum value should be 100, and the major units should be 10, and the minor unit should be 1. So when you have done that, you go to logarithmic scale and select it. So when you have done this, automatically the graph have changed to logarithmic graph. Let's look at it and see how it is. Look at it. This is how it is. You can see that this is a perfect logarithmic graph. So we want to put it more, so we can select this. So you can see how our graph is now. So you delete this now. So you can expand the graph to look more trendy. So now we need to move this to the side of the paper. So you right click on it and say format axis. So when you say format axis, you go to this place. Let's move this so that we see what we're doing. So you go to here, you have none, and put outside. So it should be minor tick marks. This label should be low, so you can see it. So S label low, so that's where we got it. So you can see that we have succeeded in moving this outside. So this is your y-axis, this is your x-axis. So you can label it from here. You can change this. You double click on it and you remove the values. So that is percentage passing, or sometimes we call it percentage final. Here you have sieve size. So we have sieve size. So we have labeled the drawing. So you can open down here, click here, so you can select any type of a kind of graph that you want. The one that has a header, you can select. If you select this one has a header, you can see it. You can see the difference. But whatever you have done in the other one, you can still do it in the one. What you just do is to remove this. This can be removed because we don't need it here. This can be removed. So what you now do is to bring out the minor and major grid lines. So this is add major grid lines. Can you see it? And I click again. Add minor grid lines. Look at it. So the table, the name of the table, the chart, you can say is particle size distribution charts. So that is it. So let's do again. Particle size distribution charts. So that's the title of the chart. So we can see how we are able to plot our Sieve analysis graph. All these things are automated. If you change the value of the number, the whole thing continues to change on its own. So you can see how we are able to generate these our values. Now, if in a situation whereby we are asked to calculate D60, that is our CC, our CU, and all the rest of them. Now you supposed to use a method called interpolation. That's the method you're supposed to use to achieve that. So let's go back to our text. Let's go back to our text. So let's look at this place. Now, this is the text we are using. So let's go to where they discussed about interpolation so that we'll be able to understand how to make use of some of these things in creating our work. So let's move now. Never confirm. Confirm. So let's get back. Okay. So move a little bit down. Okay. So interpolation. So we can see the formula for interpolation. I believe I have said this in class before. This is y is the value that you are looking for. This is yi, the first one on the top. Then you have the yi plus 1, second one down, and you have yi and x values. So when we have a situation whereby we want to find d values, so it happens that we are going to use interpolation. So for us to use that interpolation, let's take a look at this example. This is grain size, this is percentage final. Now here you are required to find the D10, D20 and D30. So the example here, they made use of the formula for interpolation to find the values of D10, D20 and D30. So what you do now is to come back to your Excel and create here maybe somewhere here. Somewhere here we'll create our D, create our 10, call it D20, D10, D20, sorry, D13 and D16. So we have created these values, so we can push them to this place, because this is the value where you have D. So for us to get the value of D10, remember what is D10? D10 is the corresponding value. When you say D10, you come to this point and check where you have 10. You count, this is 20, so you have 1, 2, 3, 5. So it should be at the middle. So when you count the middle, you trace anywhere it touches this graph, you come down. That is the value of your D10. So you can see that this can only be achieved through interpolation. Let's go back to our text. So you can see that they say that D10 is equal to A10 times brackets A11 all over A10 brackets times D13 minus B10 brackets all over B11 minus B10. So you can see that here your A10, these are A, these are A10. A10 is the upper of what you are looking for. A11 is the lower. Okay, so if you go back to the formula, remember you have y brackets y I plus 1, y I plus 1, then you have yi multiply all over. So yi should be the first one on top, while the second one down is, that is A11, is yi plus 1. So if you go back to our distance to manipulate that, we're going to have equals to our A10 here is going to be so the final percentage final, which is now your A10 is going to lie between 16 and 2. It's going to lie between 16 and 2. So the upper one, the A10 is the upper one. So we have this times brackets The lower one is this all over this again, brackets shift times this value, which is what we are looking for. So we create it, we'll have it, because it is going to be the value that we are looking for at this time. So